Hello class, in this lesson we'll be learning how to prove and how to apply Pythagorean Theorem. So here's a warm-up, and this is going to help us out with our proof. So first we want to write an expression in terms of c for x and y. So how are x and y related to c? Well, hopefully you see that if you add up x and y together, you get c, that hypotenuse of the big triangle. And what three triangles are similar? So if you can write a similarity statement there, and make sure that the corresponding vertices match up. Make sure that the smallest acute angle matches up with the other small acute angles. Make sure the right angles match up. Make sure the larger acute angles match up. So here's one correct similarity statement you could have written. As long as the corresponding vertices are in the right spots, you have a correct statement as well. And now finally, and perhaps most importantly, is let's complete this table below. So I want you guys to fill out this table like we did in a previous lesson on our similar right triangles. So fill this out using the information from this diagram, and then I'll show you my solution. So if you filled it out correctly, you should have something that looks like this. The small triangle had legs of y, h, and hypotenuse of b. Small, larger, hypotenuse. The medium triangle, smaller leg is h, medium leg is x, hypotenuse is a. And in the large triangle, the smaller leg was b, larger one was a, and the hypotenuse was c. So there we go. So what we want to do now is we're going to prove Pythagorean theorem by writing proportions, because we know that since we have similar triangles, we can write proportions to figure out what missing distances are. But in this case, everything's going to be a variable. So first thing, like we did before, draw an altitude from the right angle to the hypotenuse and label it like we have before. So same diagram as the previous example. What we know about the original triangle, the big one, and the two small ones, they're similar. And we already saw that. We wrote a similarity statement. So we know that in Pythagorean theorem, there's an a squared, a b squared, and a c squared. So the idea here is we want to write a proportion that gives us an expression that involves a squared or b squared. So first, we want to figure out the two triangles that have angle B as one of their angles. Which two triangles have angle B in them? Well, the big triangle, the large one, ACB, and the medium one also has angle B. Right, we're talking about this angle over here. So since they're similar, we can write a proportion. And we want this proportion to involve A, because A is a part of both the medium triangle and the large one. So let's look at what we have here. And the longer leg of the large triangle is A, and the hypotenuse of the medium triangle is A. So if we're going to write a proportion here, we have to involve this x here and this c. So what can we write? We can write that x over a equals a over c. And if we apply the cross product, what do we get? We have a squared over here. So a squared is x times c. Now we want to repeat this process to figure out what b squared is. So which two triangles have angle A as an acute angle? So now we're looking at this angle over here. That would be ACB and ADC, the small triangle and the large one. So let's see, what proportion can we write that involves B? I want to involve B in the proportion. Well, in the small triangle, B is the hypotenuse. And in the large triangle, B is the shorter leg. So if we're going to use these two triangles, the small and the large one, we have to involve Y here because of this B over here. We have to involve C because of this B down here. So now we can write Y over B equals B over C. And now we apply the cross product, and we get YC equals B squared. So now we want to show a squared plus b squared is c squared, and we already know what a squared and b squared are equal to. So I'd like to see if you could finish it from here. Try adding these two together and see if you can end up with a squared plus b squared equals c squared, and then I'll show you my solution. So if we add these two together, we get a squared plus b squared is xc plus yc. And we have a common factor of c here, so we can factor that out with the distributive property. So we have x plus y, that quantity, times c. But what do we know x plus y is equal to? X plus y equals c. So that's really c times c, which is c squared. So now we have Pythagorean theorem proved. Now remember, we also have the converse of Pythagorean theorem. We know that if we have a triangle with side lengths that satisfy this equation, then the triangle is a right triangle. So now this is going the other direction for Pythagorean theorem. So how can we prove that? Well, here we have a triangle with side lengths that satisfy this equation. And we don't know right now if this is a right angle over here. A little question mark there. We want to prove that. We want to prove that that's a right angle. So to do so, we're going to make another triangle that has a right angle, and the two legs are going to have lengths A and B. And we want to show that these two triangles are congruent, so then this angle would have to be a right angle because corresponding parts of congruent triangles are congruent. So how could we show that? Well, we don't know anything about the angles in the top triangle, but in this bottom triangle, we have two legs, and we already proved Pythagorean theorem. So we can figure out what the hypotenuse measures. So if we apply Pythagorean theorem, we have a squared plus b squared is c squared. And so if we take the square root, c must be the square root of a squared plus b squared. So notice that we started off not knowing that this length was c, but by applying Pythagorean theorem and what we knew up here, a squared plus b squared is c squared, we now know that this hypotenuse is the same length in each triangle. So now we can apply which criterion? The side criterion. All three sides are congruent, so these two triangles are congruent. So therefore, the corresponding angles are congruent, and this has to be a right angle. So that is the converse of Pythagorean theorem. So now let's apply some problems, or solve some problems using Pythagorean theorem. And we want to write our answers as in simple radical form. So we don't want to round decimals. We want to keep radicals in our answers. So find length of the hypotenuse if the legs are 50 and 100. So try to solve that on your own, and I'll show you my solution. So those are the legs, so we plug those in for A and B. So c squared is 2,500 plus 10,000. So c squared is 12,500. To solve this, we take the square root. Now, is that a perfect square? No, it is not. So we have to figure out what's the biggest perfect square that goes into it. Now, sometimes that task is pretty difficult if the number is pretty large. So what you might want to do is actually break it up into multiple perfect square factors. Usually it's more work, but with big numbers, sometimes it ends up actually being easier. So you notice this ends in 2 zeros. So we know 100 must be a factor. And so this, we could write this as 100 times 125. But 125 we know has a factor of 25. Right? 25 times 5 is 125. So I broke this up into 3 factors. And these first 2 factors are perfect squares. So in reality, the biggest perfect square would be 25 times 100, 2,500. But maybe it's not obvious that that's a perfect square that you want to use here. So you can always break it up into smaller factors. Square root of 100 is 10, square root of 25 is 5, 10 times 5 is 50. So 50 times the square root of 5. And we can go ahead and double check that that is numerically equivalent to our previous decimal. There we go. So that's the simplest form, right? We can't simplify that 5 anymore. Another way you could have done this is by simplifying with GCF. So you can read through this method. Essentially, you're doing a reduction, so you have smaller numbers, then doing the Pythagorean theorem, and then enlarging it back to the original size. So this method will also work. It's up to you how you want to solve these problems. Here's one where we know the length of the hypotenuse and the length of one leg. Figure out the length of the other leg in simplest radical form. So try this on your own, and then I'll show you my solution. So now we always plug in the hypotenuse for c. So that's got to be over here by itself, c squared. 20 squared, 24 squared give us 400 and 576. Subtract 400 from both sides. Oops, that should be a exponent. There we go. I want to undo that squared, so we take the square root. And is 176 a perfect square? Doesn't seem like it's one. Not familiar. No, it's not. So what's the biggest perfect square that goes into it? So look at half of 176. So the biggest it could be is 88. So you got to check from 81 down for perfect square factors. It turns out that 16 times 11 is 176. Square root of 16 is 4. So 4 times the square root of 11. In this lesson, we learned how to prove and apply the Pythagorean theorem. Thank you for watching this video.